Today, we're going way out there, like really far out. We're talking interstellar travel. Think humans, spaceships, boldly going beyond our solar system. The question we're tackling, will we ever actually make it to other stars?
It's a question that has fascinated humans for centuries.
Oh, absolutely. And to guide our deep dive today, we'll be drawing on a podcast episode called Interstellar Travel. Will we ever leave the solar system? Should be an interesting one.
Definitely. And I think what's really fascinating right off the bat is the immense scale involved. Like, imagine being on a generation ship where your grandchild would be the first to step foot on a new planet. You'd be saying goodbye to Earth, knowing you'd never see it again.
Yeah, that's a pretty heavy thought. So to even begin wrapping our heads around this whole thing, maybe we should start with the basics. Like, just how vast are these distances we're talking about?
Well, let's just take the closest star system to our own, Alpha Centauri. It's over 4 light years away.
4 light years. Okay, so that means...
It means that light itself, traveling at, the speed of light, takes over 4 years to get from there to here.
And just to put that in perspective, light from the sun takes about 8 minutes to reach Earth.
Exactly. So with our current technology, even getting to the nearest star system would take thousands of years.
Thousands, wow. Okay, so if we're ever going to reach another star within a human lifetime, speed is the biggest issue, right?
Absolutely. The fastest human-made object we have right now is Voyager 1. It's zipping along at about 17 kilometers per second. But even at that speed, it would still take Voyager 1 over 75,000 years to reach Proxima Centauri.
75,000 years. So basically not happening anytime soon.
Nope. Not with that tech, anyway. To even consider interstellar travel within a human lifespan, we'd need to be traveling at something like 10% the speed of light. That's about 30,000 kilometers per second.
Okay, so warp speed, basically. But how do we get there? What kind of out there ideas are scientists exploring to make this kind of speed possible?
Well, there are a few really interesting possibilities. One idea is nuclear fusion rockets, which would harness the immense power of nuclear reactions for propulsion.
Fusion, huh? That sounds pretty futuristic. But haven't we been struggling to make fusion power work here on Earth?
Yeah, that's true. It's definitely a challenge, but you never know. Even a small breakthrough in fusion technology could have huge implications for space travel. And it's not just fusion. Another idea, even wilder, is the antimatter engine.
Antimatter. Okay, now we're talking. That sounds almost like something out of Star Trek.
It kind of is, but the concept is rooted in real physics. You see, antimatter is basically the opposite of matter. When they meet, they annihilate each other, releasing a truly mind-blowing amount of energy. We're talking about the potential for near-light speed travel here.
Oh, near-light speed. But there's got to be a catch, right? Can't be that easy.
You're right, there is a catch. The biggest hurdle with antimatter is producing it in large enough quantities. It's unbelievably expensive right now.
Ah, so not exactly a practical solution just yet.
Not yet, no. Maybe a bit more down to earth, so to speak, is the idea of light sails.
Light sails, like actual sails, pushed by light.
Exactly. The idea is to use powerful lasers to push these giant, ultra-thin sails through space. There's actually a project called Breakthrough Starshot that's exploring this concept. They're aiming to send tiny probes to Alpha Centauri using this technology.
And these little light-powered spacecraft, how fast could they theoretically go?
They could potentially reach 20% the speed of light, meaning it would only take about 20 years to reach Alpha Centauri.
Okay, 20 years is still a long time. But compared to those thousands of years we talked about earlier, that's starting to sound almost within reach. But even if we crack the speed problem, we still have to think about surviving out there in deep space, right?
Yeah, you're hitting on a really important point. It's not just about getting there fast. It's about surviving the journey. And that's a whole other set of challenges.
I bet. And I'm guessing those challenges go way beyond just packing enough snacks for the trip.
Oh, yeah, definitely. When you're traveling at those kinds of speeds, even tiny dust particles become like little bullets. Cosmic radiation is another huge issue. Shielding against these hazards is essential, but the more shielding you add, the heavier the spacecraft becomes, which slows you down.
So it's a delicate balancing act. Speed versus protection.
Exactly. And then you have the human element to consider. How do you keep astronauts healthy, both physically and mentally, on a journey that could last for decades?
That's true. It's not just about building the right spacecraft. It's about understanding the human impact of interstellar travel as well.
Absolutely. We might need to develop things like self-sustaining life support systems, maybe even something like a generation ship.
A generation ship. So people are born, live their entire lives, and die on this spaceship, all while hurtling through the void.
It's a pretty wild concept, right? But it might be the only way to make these incredibly long journeys possible. And then there's the whole issue of communication. We take instant communication for granted here on Earth, but at interstellar distances, messages would take years to travel back and forth.
Yeah, so no quick calls back home to check in with family.
Not exactly. It would be more like sending a message in a bottle and hoping it reaches its destination someday. But, all of these challenges, as daunting as they seem, are really just practical hurdles. There are also some more theoretical possibilities out there, things that might sound like they're straight out of science fiction. They could completely change the game when it comes to interstellar travel.
Okay, now you've got me intrigued. What are the sci-fi solutions we're talking about?
Things like the Alcubierre warp drive and wormholes.
Warp drive, like in Star Trek, now we're talking.
Yeah, it sounds pretty far-fetched, but the concept is actually based on Einstein's theory of general relativity. The idea is that you create a sort of warp bubble around the spacecraft by compressing space in front of it and expanding space behind it. This allows you to effectively travel faster than light without actually breaking the laws of physics.
Okay, so it's not like the spaceship itself is going faster than light. It's more like it's riding a wave of warped space-time.
That's a good way to think about it. The problem is that to create this warp bubble, you need something called negative energy, which we haven't actually discovered yet.
So warp drive is on hold for now. What about wormholes? Are those any more realistic?
Wormholes are like tunnels through space-time that connect two distant points. It's like folding a piece of paper in half and poking a hole through it.
Yeah.
That hole becomes a shortcut between the two sides of the paper.
So a cosmic shortcut, basically. That sounds pretty handy. But how do we actually create one of these wormholes?
That's the big question. And unfortunately, we don't have an answer yet. We know that wormholes are theoretically possible based on Einstein's equations. But we have no idea how to create one, let alone stabilize it so we could travel through it.
So it sounds like wormhole travel is still pretty firmly in the realm of science fiction.
For now, yes. But who knows what the future holds? The history of science is full of examples of things that seemed impossible at one point and then became reality.
That's true. And maybe someday we'll look back at this conversation and laugh about how primitive our understanding of interstellar travel was. But for now, we're still stuck with the reality of the immense distances, the technological hurdles, and all those other challenges we've been talking about. So with all that in mind, is interstellar travel even worth it? What are the potential benefits that make this dream worth pursuing?
That's a great question, and one that we'll explore further after a quick break. Stay tuned. It really makes you think, about why we're even trying to do this. What's the point of reaching for the stars when we have so many problems right here on Earth?
Yeah, I was thinking about that too. I mean, all this talk of warp drives and wormholes is super cool, but it also makes you wonder, what's the big payoff? Why are we so obsessed with this idea of interstellar travel?
Well, I think part of it is that innate human desire to explore, to push the boundaries, to see what's beyond the horizon. It's kind of what we do, right? We climb mountains, we sail across oceans, we send probes to distant planets. We're always looking for what's next.
It's like we have this built-in need to explore the unknown. And I guess in that sense, space, especially the vastness of interstellar space, is like the ultimate frontier.
Exactly.
Yeah.
It represents the biggest unknown we can imagine. It's full of mysteries, of potential discoveries, of things we can't even begin to comprehend right now.
So it's not just about finding a new home for humanity or escaping Earth's problems. It's also about the sheer wonder of discovery, the possibility of encountering something truly alien, something that could change our entire understanding of the universe.
Right. And who knows, maybe we'll even find evidence of other intelligent life out there. That would be a total game changer, wouldn't it?
Imagine that. To actually know that we're not alone in the universe, it would be incredible. And suddenly all those challenges we talked about, the distances, the dangers, it might not seem quite so daunting anymore.
Maybe not. But even if we don't find aliens, the technology we develop to achieve interstellar travel could have huge benefits for life here on Earth. Think about the Apollo missions, for example. They led to all sorts of technological spin-offs that we use every day.
Yeah, it's amazing how those efforts to reach the moon ended up having such a big impact on technology back here on Earth.
Exactly. And the same thing could happen with interstellar travel. The research and development required to achieve this goal could lead to breakthroughs in material science, propulsion systems, energy production, all sorts of things.
It's like that saying, shoot for the moon, even if you miss, you'll land among the stars. But let's be honest, there's another reason we're so interested in interstellar travel, and it's not just about scientific curiosity or potential technological spin-offs. It's about survival, right?
Yeah, that's a big part of it too. We've already talked about some of the threats facing Earth. Climate change, asteroid impacts, the eventual death of our sun. Interstellar travel offers a way to hedge our bets to ensure the long-term survival of our species by spreading out to other worlds.
So it's like a cosmic insurance policy, a way to diversify our portfolio, so to speak, not putting all our eggs in one planetary basket.
Exactly. And, this idea might sound like science fiction, but it's something that serious scientists are thinking about. Stephen Hawking, for instance, was a big proponent of space exploration as a way to safeguard humanity's future.
Yeah, it makes you wonder what kind of future awaits us if we do manage to establish colonies on other planets. Will we become a multiplanetary species, branching out in different directions? Will we even still be human as we understand it now?
Those are really big questions, and to be honest, I don't think anyone has the answers. But that's part of what makes this whole topic so fascinating, right? It forces us to confront these really profound questions about our place in the universe, about our past, our present, and our future.
It's like holding up a mirror to humanity and asking, who are we and where are we going? But for now, we're still stuck on this little blue planet with all its beauty and all its problems. So how do we get from here to there? How do we bridge the gap between our current reality and this dream of interstellar travel?
Well, I think a lot of it comes down to those sci-fi solutions we were talking about earlier. The warp drives, the wormholes, the things that might seem impossible now, but could be the key to unlocking the true potential of interstellar travel.
Okay, so let's dive back into those. We talked about the Alcubierre warp drive and how it needs this negative energy to work, which we haven't discovered yet. Are there any other ways to achieve faster than light travel?
Well, there are some other ideas out there, each with its own set of challenges and possibilities. One that comes up a lot is manipulating extra dimensions.
Extra dimensions. Okay, now you're really taking us down the rabbit hole. What does that even mean?
It's a pretty mind-blowing concept, but essentially it's based on the idea that there might be more to the universe than the 3 spatial dimensions and 1 time dimension that we experience. Some physicists believe there could be additional hidden dimensions that we can't perceive directly.
So it's like there are these secret pockets of reality hidden within the fabric of space-time.
Exactly. And some theories suggest that if we could access and manipulate these extra dimensions, we might be able to create shortcuts through space-time. It's kind of like finding a secret passageway that lets you travel between 2 points without having to traverse the entire distance in between.
It's like a cosmic cheat code. But again, this all relies on proving these extra dimensions actually exist and figuring out how to use them to our advantage.
Right. It's definitely still in the realm of theoretical physics, but it's a good example of the kind of outside-the-box thinking that might be necessary to achieve truly groundbreaking breakthroughs in interstellar travel.
It's a reminder that we need to keep an open mind, to explore all the possibilities, even the ones that seem the most far-fetched. Because sometimes the craziest ideas turn out to be the ones that change the world.
Absolutely.
Yeah.
And who knows what amazing ideas future generations will come up with. We might just be scratching the surface of what's possible.
It's both exciting and humbling to think about. But before we get too carried away with all these far-out concepts, maybe we should bring things back down to Earth for a moment. We've been talking a lot about the technology and the challenges of interstellar travel, but there's another really important aspect we haven't touched on much. The human factor. What kind of impact would interstellar travel have on society, on our culture, on our very understanding of what it means to be human?
Yeah, that's a really important point. It's not just about the technology. It's about the people who will be making these journeys and the impact it will have on them and on humanity as a whole.
Exactly, because interstellar travel isn't just about reaching distant stars. It's about pushing the boundaries of human experience, and that's a whole other conversation. It's wild to think, with all this talk about interstellar travel and these massive ships, what would it actually do to us, to humans and our society if we ever get out there?
Yeah, it's a huge question, right? Just thinking about leaving Earth behind, it could completely change who we are as, humans.
I know. It's like right now we're all stuck here on this one planet, all sharing the same, everything, air, food, you name it. But if we start spreading out to other planets, setting up colonies, who knows what could happen?
It'd be like starting over almost. Imagine the changes. Humans adapting to different planets, different gravity, different air. Would we even have the same kind of governments?
I was just thinking that. What would the culture be like? Would religion be different? And art? Would we even recognize those things after hundreds of years on other planets?
It's almost impossible to imagine. And then there's biology too. Evolution. Would humans on other planets evolve differently? Would we look the same?
It's mind-blowing. What would it even mean to be human anymore if we're no longer just from Earth? Would we even be one species?
It's a question science fiction has been asking for ages, right?
Yeah.
And now it's becoming more and more real as we get closer to maybe actually doing this, traveling to the stars.
You know, even if we don't figure it out, even if we never actually travel to other stars, just thinking about it, just trying to solve these problems, it's making us think in new ways. It's making us question everything.
That's so true. We're pushing the limits of
Right.
science and tech. Yeah. But also, what are the ethics of all this? Like, what if there's alien life out there? Should we even be colonizing other planets?
It's a lot of responsibility.
Mhm.
And then there's the cost, right? All
Right.
those resources. Should we be spending so much time and money on this when there are so many problems here on Earth?
Exactly. It makes you realize that interstellar travel, it's not just about building spaceships. It's about philosophy, about ethics, about our values as humans. It's a huge undertaking.
Really makes you think. It's not just about reaching other stars. It's about understanding who we are, what our place is in all of this, in the universe, and what we owe to it.
Well put. And maybe that's the message to take away from all of this. It's a journey outward to the stars, yeah.
Mhm.
But also, it's a journey inward to understand ourselves.
It has been an amazing deep dive. Thanks for joining us as we explored all this, the distances, the tech, the challenges, the big questions. Hopefully it gave everyone out there something to think about.
It's been a pleasure. And who knows, maybe someday, looking back, this conversation will seem like, well, just the beginning. Maybe we'll be out there among the stars.
That's a future I'd love to see. So until then, keep looking up and keep dreaming. And thanks again for listening.